Hi, hello everyone. In the previous video, we already learned about one-to-one function and which cases when the function is not one-to-one. That is, when we use algebraic approach, we will get two different values of x1. And if you are using horizontal line test, we'll find out that at the graph, there will be two intersection points between the horizontal line and the graph. Now, we continue our discussion with an example relating the restricted domain. So this is what we call restricted domain. Because in general, the domain for the quadratic function would be all real numbers, that is from negative to positive infinity. But now, we already restricted to be greater or equals to 0. And also, we notice that this is a quadratic. So remember from the previous video, for quadratic function, in order to find out specifically the range, you need to using completing the square and find the minimum point. So in this case, x squared minus 4, so when we compare with a x minus h squared plus k, so it's actually will be like this because there's no x right here, so straight away it can be like this, right? So here we find out that the minimum point is 0, negative 4. But we need to show whether it is one-to-one function using algebraic approach. So from algebraic approach, we will substitute x with x1 on the left side and x with the x2 on the right side. Okay, and then we can cancel out negative 4, and then x1 squared equals to x2 squared. So remember the previous video, when we eliminate the square, so here it would be square root of square, so it would be plus minus x2, which would be not one-to-one function. But here, our domain here, given x greater or equals to 0, so therefore we will omit the negative solution and we will consider the positive solution only. So at the end, we will get x1 equals to x2, then the result will be, yes, one-to-one function. So the same also apply when we use horizontal line test. As I showed before, you need to find out the minimum point, right? So the original graph would be like this one. So if we sketch the horizontal line, they will intersect at 2 points, correct? However, in this case, since the domain x greater or equals to 0 and 0 is at minimum point, so we will consider the positive values only. So the graph now will become like this. So this is the minimum point, 0, negative 4. So 0 at x. So this is y-axis, and then negative 4, which is below x-axis. So something right here. Okay. And then sketch the line, horizontal line, y equals to k. Right? And you can point out here, there will be only one intersection. And don't forget, after we show in the graph, you have to write a statement. As usual, that is line y equals to k intersect the graph at one point only. Therefore, it is one-to-one function. Right? So this what happen if we restrict the domain for quadratic function. Okay, next for question F. So in question F, f of x is absolute of x plus 2, where x greater or equals to 0. Remember, this is absolute function. And absolute function, we have positive and negative definition. So, positive definition will start at negative 2, right? So here, how we get negative 2? So before that, you need to equate with 0. So x equals to negative 2. So this is how we get x greater or equals to negative 2 for positive definition. And for negative definition, so for x less than that is less than negative 2. So in the first step, we write as usual. That is on the left side, modulus of x plus 2 equals to absolute of x2 plus 2. And then, since x greater or equals to 0, so we will use positive definition only. So now it would be x plus 2 positive definition, and also right side positive x2 plus 2. Okay, using positive definition, and then eliminate 2, and then we'll get x1 equals to x2. So now since we got x1 equals to x2, then we can conclude that it is f is 1 to 1. Then how about horizontal line test? So remember, for horizontal line test, you need to sketch the graph, right? So remember the graph. So the cutoff point is at negative 2 for positive and negative definition. But now our domain start at 0, right? So we start at 0, and then we don't sketch before 0. So it will be like that. So here you can see we only sketch the positive definition. That is more or less like a linear function. So if we sketch the line y equals to k, it can clearly show that the graph intersects at one point only. So write the statement below here. There is line y equals to k intersects at one point only. Therefore, f is 1 to 1. Right. So as a conclusion, what can we get from these two examples? Yes, that is when the domain is restricted. If you're using algebraic approach, there's only one value of x1. That is x1 equals to x2. And if you're using horizontal line test method, we will get only one intersection point on graph. Therefore, in both cases, we can conclude that f is one-to-one function. So this is for restricted domain. So that's the end of this video.